So we were building this cool car and we found out we were missing one of these pieces. And to stop from building this car would be kind of sad. It would be sad. So we're going to 3D print one.
To start designing a replacement for this part, we need to measure it, and ruler is not a good choice, certainly. Any sort of cheap Vernier caliper would do. You can buy it at any hardware store, $3 to $5, nothing fancy necessary. Let's learn how to use that. So these main jaws of Vernier caliper are used to measure thickness of something. So I have these tweezers and I'm measuring this part of tweezers. So first we find which is the nearest big fraction, nearest millimeter on the main scale. So this is 1, it's just something under 2 millimeters. And to find it, we need to find two most aligned marks on this scale, on this lower scale, on Vernier scale, to find out what's the actual thickness of this part. So this would be something between 0.8 and 0.9. So let's say it's 1.9 millimeters. If we want to measure depth of something, for example, we have this chopstick holder. We just take this part of caliper and put it in an object which you want to measure, and you roll it until it hits the surface and the bottom of this hole you want to measure. So this would be how deep this hole is, and we look at the scale. It's something, you can see it's 2 centimeters mark, so this something around 1.5 is just a bit less than 1.6, and nearest aligned marks are this and this. So this would be 15 millimeters, 15.5 millimeters. And if we want to measure inner diameter of something, we can use these secondary jaws. For example, I want to measure diameter of this hole. So what I do, I push these jaws inside of this hole and I stretch it. And I take it out, and we can see that this hole is roughly, well, not roughly, it's exactly 5 millimeters, because see, the starting mark matches and the end mark matches. So this means that it exactly hits this one. So could be something like 5 millimeters, 0.01 or something, very close to 5 millimeters. All right, let's start creating a replacement. I started a FreeCAD. There are many other options available, but this one is completely free and open source, so you can use it to create your parts. I created a new document, and the first thing I'm going to create a variable set. And I'm going to add a first variable, which is going to be inner diameter of this hole in this part. So let's measure it first. It seems to be something around 6.1 millimeters. Yeah, let's write it down here. Inner D. And diameter 6.1. Okay, so we created variable set. We can see variables here. And next thing, we will create a sketch on this XY surface. I will create 2 circles on X and we'll make them equal for now. And now we can apply dimensions to these circles. I'm going to click this little button here, which will allow me to use variable set. So I will choose var set and inner D, which is 6.10, 6.1, and both circles have changed the diameter because I already marked them as equal. Next thing, let's measure the outer diameter of this part. What is that? Something around 8 millimeters. Not that important, we probably can make it a bit bigger. Alright, back to FreeCAD. So first of all, we're going to close this process with tasks. Click on Verset, and now we can add a property which is going to be outer D, and we can set a value here to 8 millimeters. I think it's the time to save the document. Ball joint. Now we can go back to sketch, create 2 more circles, make them equal again, and add a dimension, apply our variable. Looks good. Maybe a bit slim. Maybe we can make it something like 8.5 just for extra strength. Compute object, so the variable is updated. Now we're going to create 2 vertical lines. And when you hover over another geometric object, you can see it suggests that it will create a coincidence point. So let's use that. And when you make it vertical enough, it will also create vertical constraint. Let's make it same for another line. Now we want to make them symmetric. So to make them symmetric, we need a line and 2 points. So we select this point, and then select x-axis. So they became symmetric. Now when we have that, we want to measure this distance. So here's our part. Maybe we will use inner measurement part to measure it from here to here. Because this is the distance we care. Oh, hold on. We actually care most about distance from this point inside here and to this point, to make sure we have effectively the same length in the construction. So let's measure it like that. And this would be 34 millimeters from inner to inner. All right, we are back to FreeCAD. I think what we're going to do, we're going to create a dot here and similar dot here. coincident for this dot and x-axis. Same here. To move the screen like that, hold Shift and hold middle button of the mouse and drag it. If you don't hold Shift, you will change viewing angle, which you can later fix with this thing. You can keep clicking on different edges of this cube and it will rotate it conveniently. Alright, now we have these two dots. We want to add distance constraint for them, length constraint. We still didn't create a variable. So let's cancel it, close tasks, go to variable set, add a property, and we call it inner to inner. And we set it to 34 millimeters. And now I won't hit enter, because when you hit enter it goes to the start screen somehow. Let's just close the start screen. Alright, now click to the sketch to get back to the sketch, and yeah, but I made a mistake. I added these dots at the wrong place. Let's fix it. So maybe we just delete these dots, delete this dot, add new ones, one here and one here, because we measured from inner circle to inner one. Yeah, let's make them coincident with x-axis and get back to our dimensions. Cool. Looks good. And I think we are nearly there. Well, nearly. So the next step, we need to measure width of this part, or maybe thickness if you like. So we take it into jaws, 4 point something. More like 4.7. You see this 7 mark is aligned with another mark on the main scale. So yeah, let's make it 4.7. We close this, we go back to var set, and we add a property width. Well, actually I think maybe it's better to call it height, because you know, it's like if we lay it on the surface, this would be a height of this part, and width would then be this, which is roughly the same. Let's measure it again. So this more maybe actually more like 4.6, and this one is, yeah, this one is 4.7. So okay, let's create width and set it to 4.7, and we add another one, we call it height. And we call it 4.6. Cool. Now when we have this sketch and it's all looking good, we need to remove some pieces of this sketch here and here, and hit ESC to cancel the object. Let's see if anything is unconstrained. Right, this one is not constrained, so we need to make these coincident. Did it work? No. Let's just move them apart. Select this, hold Control and select another one and make them coincident. All looks good. This one is still not constrained, so this would be our width. So let's add a dimension. Set width. And we're almost ready. Still something a bit off here. Let's try again. These two dots. Or constraint. Did this one work? So maybe we make it coincident with a line rather than with dot. Yeah, that worked. So it all looks green, which means this part is fully constrained. There are no unconstrained variables, which means we measured everything we could. So we close that, we select the sketch and select pad tool, and this pad tool allows us to select the length to extrude it to the top. So we select var set height, and it's done. Look at that. We are nearly there. So the next step is a bit interesting. This part has little lips inside to make sure that joint doesn't pop out of here, so it kind of sits inside it. It is loose, it's easy to move it, but it doesn't pop out. So we need to figure out how to reproduce these lips. So we finished with this pad, and we can see that all other actions are disabled. This is because we didn't close the pad process. So we click here and all these things are available again. So I think we'll use additive primitive of torus to enhance our part with some lips. So we'll select this edge here and see we have huge torus here, and now we can play with this torus. So it has two diameters. One diameter is diameter of the torus here, or it's actually radius. Let's make it 1 millimeter. Would it look different? So we can roll and see this is a huge torus. So what we're going to do now is get back to editing this, and we try to set one of those diameters we have. I think outer diameter is probably okay. And we want to also divide it by 2, because that's what we have here, it's a radius. Let's see how it looks. We have huge thing sitting on the top here. So let's get back to our torus. I think 1 millimeter of a radius is too much. Maybe set it to 0.2, and it sits on the outer side. It's maybe not what we want. So let's try to do the same with inner diameter divided by 2. Looks more like what we want, but it sits slightly on top, and it's maybe sticking too much. little bit, 0.2 millimeters. It's important to use units here. Right, so it has, we subtracted this diameter we have from this radius we have from this one, so it is ending on the edge of this inner hole. And now we're going to move it a little bit in that direction to minus 0.2 millimeters. See how it looks. So it shifted down a little bit. I think we need to take caliper again and see how far it actually goes into this hole. Maybe a bit too dark. I'll try to move it here. It's a little bit hard to measure, so I'm trying to put the end of this thing onto a lip in here to measure how far it is. And it seems like it is half millimeter, 0.5 millimeter. All right, so back to FreeCAD. So we're going to shift it on that direction by 0.5 millimeters, or maybe make it a little bit more, 0.6. Yeah, looks good. It's probably too much. 55. And we're going to shift it in X direction just a little bit. So see, it makes it to protrude from here and not to be here. It's similar to what we have in actual part. So maybe we can make it like that. Yeah, I think it's good enough. I believe this is the time to save it into variables. So this would be lip diameter. Let's call it lip diameter. Property lip D. And we can put a formula here. So let's get back to our torus. So we have width or thickness of this torus 0.25. Actually would be half millimeter with radius 0.25. Let's get back to here. I think this should be lip radius because we use it as a radius. Lip R, and we paste this formula. We can delete this one. We add another property for lip thickness, if you like. Well, it's actually a radius. It's called lip RE. We set it to 0.25 millimeters. And let's see which offsets we have. We have 50 micrometers, which is 0.05 millimeters, and 0.55 millimeters in that direction. Let's set it. X offset, and we paste this value here, and we add lip Z offset, and we set 0.55, and looks good. Now we can apply all these new variables here. This would be lip X offset. This would be Z offset. Lip R. Oops, I broke something. Alright, because we want it to be negative. Yeah, looks good. So what we're going to do, we're going to apply the same effect to this edge here. So we're going to close this torus and create a new one here, and apply all these variables to these torus as well. The lip R, lip RE, offset, and that Z direction. And we want to make it negative as well. Cool, looks good. So now we can close it and have a look. Yeah, I think it can hold our ball joints. Now we'll do the same from the other side. Maybe to make sure it holds them properly, we can change the direction of X offset here. Let's make it negative. Cool. So these lips shifted in different directions, different sides. What we have left is this one. Let's quickly create it as well. direction here as well. Alright, I think we are ready to export this part, slice and print it. To export it from FreeCAD, it is important to select specific body you want to export. So we selected this part, we're exporting it. Open it in slicer of your choice and slice it. You can play with some settings, but this is out of scope of this video. This part looks good. Let's change the color and start printing. Now the part is printed and it seems to be functioning properly.